Hello friends, welcome to Catalyst Chemistry YouTube channel. As we discussed last video, important points about the Sandmeyer reaction, the next one is what? Diazotization. Okay, these 2 points are most important. Okay, make it perfect. Today we are going to discuss the continued part, that is called what? Physical property of what? Haloalkanes. After that we are going to discuss about the chemical property, next chemical property, after that most important SN1, SN2 will come. Okay. Physical property, in this case completely importance on what? Haloalkanes. We are not going to study about haloarenes right now. Physical property of haloalkanes means the most important in this case what? The size matter. After that what? Boiling point. The boiling point for only for what? Liquids, and melting points for what? Solid. These 2 points are most important. Boiling point for liquids, next one is melting point for what? Solid compounds. Okay. Next important first point, in this case physical property, the first point is there, that is what? Boiling point related. Before that we are going to talk about what? Color means what? In this case pure haloalkanes we are going to consider, that is what? Colorless. But if you are going to consider bromoalkanes and iodoalkanes, these two are what? Colored when exposed to light, otherwise you can store a longer period or a time. That is what most important. But if you are going to consider chloroalkanes is usually what? Colorless. These 2 points are important. Okay. Next one is what? Important, that is called what? Boiling point order. Just see here, down the group the boiling point is going to increases. Why down the group boiling point is going to increases? Boiling point is completely depends on molecular weight. Which compound or which element is having a what? Highest molecular weight, that is having a what? Highest boiling point. You know very well about that. The first in halogen family, first important part is what? That is fluorine, chlorine, bromine, iodine is there. Down the group obviously the size is going to increases. If the size is going to increases 100%, the molecular weight is also going to increases. That is why the down the group the boiling point is going to what? Increases. Just here I am going to give one small clue for you. Just here I am going to write here only, after that I will rub it. Just here fluorine is there, chlorine is there, bromine, next one is what? Iodine. Just here the fluorine is having a what? Smaller in size, very small size fluorine, because of what is the atomic number of fluorine? 9, 1s2, 2s2, 2p4, 2p orbital is a very small in size. After that this is a chlorine is having a what? Larger size, bromine is again larger, this iodine is a too larger. This is a technique. Okay, bear in mind, down the group size is going to increases obviously. If the size increases, automatically what happen? The molecular weight is going to increases. Just here in this case, obvious which is having highest molecular weight? Iodine is having a highest molecular weight. Molecular weight is directly related to what? Boiling point. So that's why the order is iodine. This is R is indicate what? CS3. If you want, you can take an example like this. Okay, example I am going to write. If CS3I is having a what? Highest methyl iodide. Next after that in this case what? CS3Br is there. Next after that in this case what? CS3Cl is there. Next after that what? CS3F is there. Okay. This is the what? Order of boiling point. Down the group order is going to increase. This is what? Boiling point related. The next important point is what? That is density. What about density? Now tell me, density is also down the group is going to increases. What is the definition of density? You know, D equal to m divided by V, means that is mass equal to, here I am going to write D equal to mass by volume. This is the definition of what? Density. Mass is highest. What about a density? Density is also what? Highest. That is why density is directly proportional to mass, but inversely proportional to what? Volume. That is why down the group density is also going to increases. That point also you have to note on. Okay, in this case boiling point, and next one is what? Density. Okay, both are down the group going to increase. This is boiling point. The next third point is what? Isomeric alkyl halides are there. Isomeric alkyl halide, what is the meaning of that isomeric alkyl halide? Just see here, you know isomers, The isomers having a what branched chain like this. In this case also what happens, the isomeric alkyl halide is having a boiling point decrease. Just here, why isomeric alkyl halide is having a lesser boiling point? Just I am going to write normal structure of what this isomeric alkyl halide. Just here, and this is carbon is there, this one is carbon like this. Okay, you have to consider like this. Okay, means in this case what Cl is there. I just, if you want you can take a Cl, no problem. Our heading is what alkyl halide only. No? This is indicate what isomeric alkyl halide. This is having a what branched chain. This is having a what branched chain. This condition, this type of alkyl halide or this condition, the boiling point is decreases. The next question, why boiling point is decreases? Just see here, that is most interesting fact. I am going to make a circle like this. Okay, this is a look like a what spherical structure. You know PVC first year knowledge, spherical, dumbbell, double dumbbell like this. No, that is why in this case this is a look like a what spherical structure. If the spherical structures are there, the intermolecular force of attraction is going to what less. Means what in this case, which van der Waals force of attraction is going to what less. Van der Waals force of attraction is less, automatically the boiling point is going to what decreases. One more important point in this case, the most important point is what surface area. What is that? Now tell me, surface area. What are the main important points for decreasing the boiling point for alkyl halide? The first point is what surface area. If you want you can note down surface area. Surface area is a matter. If less surface area having a less boiling point, more surface area having a more boiling point. Surface area is their most important point. Next after that, surface area means this is, it is a look like a what spherical in structure. It is a look like a what spherical structure. It is look like spherical. It is look like a spherical. Automatically what happens, the surface area is going to what less. For isomeric, this look like a structure is what isomeric. First point is what surface area is less. Next important point, it is a look like a spherical shape. In this case what happens, the intermolecular force of attraction is what less. Why intermolecular force of attraction is less? Due to van der Waals force of attraction is what less. That is why van der Waals force of attraction means indirectly what intermolecular force of attraction only. That is why in this case isomeric alkyl halide is having a what less boiling point. Next, which is having a more boiling point? Straight chained carbons. That is what straight chained carbons. What are the straight chained carbons? I am going to write here only. Okay. This point I am going to write here only like this. Okay, just see here. Okay, Cl is there. Okay, in this case what happens, the boiling point is going to increases. The next question, why boiling point is going to increases? Just see here, I am going to consider surface area like this. Okay, this one is indicate what surface area. In this case what happens, the surface area is more. Obviously the boiling point is more. Surface area is more, boiling point is more. Why in this case boiling point is more? The intermolecular force of attraction is more. You know very well about that catenation like that. In this case what happens, this carbon attached to this carbon like this. In this case intermolecular force of attraction is high. Intermolecular force of attraction is high, obviously the boiling point is high. You know, if you want you can note down the point. If straight chained carbons are there, straight chained alkyl halides are there, that is having a what higher boiling point compared to what branched chain. This isomeric means what branched chain. This is an important point. The next one is what, that is polarity. The last one is what, solubility. Polarity, polar means what, one is a negative, another one is positive, that is indicate what, polar charge you can say. Okay, just here in this case polarity means this mu is indicate what, dipole moment. Mu, what is the dipole moment? Mu equal to q into d. Dipole moment, it is a product of charge and distance between them, that is called what, dipole moment. Okay, pole means what, charges, two charges, that is called dipole moment. In this case what happened, if the dipole moment is decreases, electronegativity increases, bear in mind, important. In this case what happened, the dipole moment is there, dipole moment is going to what, decreases, the electronegativity is going to what, increases. Just see here, in this case what important point is, This RCl is having a what higher dipole moment compared to what RF. Okay, in this case dipole moment is decreases, electronegativity is what increases. Do not consider this one. Up to this you have to consider just here, compare between these two. Okay, it is like exceptional case. This RCl is there, RCl is having a what lesser dipole moment is there, lesser dipole moment is having a higher electronegativity. Okay, RCl is having a higher dipole moment compared to what RF. RF is having a what lower dipole moment because of a higher electronegativity. Okay, why this is having a lower dipole moment? Because of fluorine is having a very small size, very means very small size. Okay, that is why in this case RCl is having, RCl means what, this alkyl chloride is having the highest dipole moment compared to what RF. Next after that RPR is there, next one is what RI is there. Okay, this is the what order of polarity, this is the what order of polarity. Okay. The next point is what solubility. Solubility means if you are going to consider alkyl chlorides, alkyl halides, you have to take any of the alkyl halide. Alkyl halide does not dissolve with water molecule. Does not dissolve with water molecule means what? It nor can it is do not form the hydrogen bonding, and next one is it cannot break the hydrogen bonding. Just here in this case you know very well about that hydrogen bonding. Hydrogen bonding means just here I am going to write hydrogen, this is oxygen and this is hydrogen. Some of the students are going to understand this oxygen is there, this hydrogen is there, this bond is look like a hydrogen bond, that is not a hydrogen bond. Hydrogen bond means if you have to consider another 1 mole of water molecule, I am going to consider just here hydrogen is there, next oxygen is there, this is what hydrogen is there. The oxygen is a more electronegative element compared to what hydrogen. That is why in this case there is a formation of bond. This bond is called hydrogen bond, bear in mind, important. Okay, hydrogen bond formation between two water molecule, not only one water molecule. This is not a hydrogen bonding, this is one is indicate what a hydrogen bonding. This hydrogen bonding is not possible in a haloalkanes or alkyl halide. If you want, you can take a alkyl halide. Alkyl halide can react with what water molecule. In this case, this process is possible. That now process is not possible. Why it is not possible? Because there is no soluble. That is why the final conclusion in this case, alkyl halides do not form the hydrogen bonding in a water molecule, or nor can break the hydrogen bonding in water molecule. It is not going to formation hydrogen bonding molecule, it is not going to break the hydrogen bonding. Okay, this is indicate what physical properties of what haloalkanes. Okay, this is most important point about what boiling point, and next one is water density. Okay, all those things you have to make a practice. Okay, thank you.